Welcome to Google Next, and welcome to this talk on designing quality APIs. I'm glad to see a reasonably good turnout. I did once give a presentation here in San Francisco, and I was scheduled in a back room at the same time as the keynote presentation with some reasonably famous speaker. I can't remember who it was. And when it came time to start the session, there was exactly one person in the audience sitting in the front row. And I was just sort of considering what to do at this point when some fellow wandered in through the back door, and it was fairly obvious from the way he was behaving that he was completely lost. He didn't know where he was. So I gave him an extremely warm welcome and thanked him for showing up to my session. So of course at this point this poor fellow's stuck. I've sort of cut off his line of retreat. So anyway, the three of us sat in the front row and just sort of chit-chatted for an hour. So I'm very happy that so many of you have turned up for this talk. So I assume you're here because you're interested in APIs, and if you're interested in APIs, you'll know that there's lots of controversy around APIs, and there's lots of conflicting advice on what to do. My experience is when that happens, it's often the case that people aren't really disagreeing about technology. The reason that they disagree is that they come to the problem with different ideas and different values. They have different objectives. They're trying to solve different problems. And so since they're actually trying to solve different problems, they tend to disagree about the solutions. So I thought I'd take a moment to talk about some of the different things that people are actually trying to achieve when they approach the problem of developing an API. This is a picture of Richard Hamming. You probably heard of Richard Hamming. He's a famous person in computer circles. He was a sort of mathematician and scientist of the 20th century. He's famous for Hamming codes, which are error correction and detection codes, which are actually still used today. They're used in RAM memory, and they're used in wireless protocols. One of the things that Hamming was famous for, in addition to Hamming windows, Hamming distance, Hamming codes, he was famous for a series of lectures that he gave, and you can find those lectures on the internet now. There's versions on YouTube as well as written versions. One of the most famous is called You and Your Research, which is his advice to researchers on how to maximize their impact and manage their careers. And Hamming himself says that although his experience is from research, his advice is useful in different kind of domains. So Hamming makes some important points, some useful points. If you really want to have an impact, then you should make sure that you're working on problems that are really important problems in your field. If you're not working on the important problems, it's unlikely that you'll do important work. Another point that he makes, in fact, this is a great talk. If you're not familiar with Hamming's lecture, then you should go and spend some time looking at it. In fact, the truth is, if you only had 1 hour to spend, you probably do better to spend it listening to Hamming than listening to me, but I'm going to assume that you have 2 hours to spend. So you're going to spend 1 hour listening to me and then 1 hour listening to Hamming. The other thing that Hamming talks about is this idea of having an attack on a problem. And for him, an attack is kind of a plausible approach that might lead to a solution to the problem, or at least make a dent in the problem. And in fact, he says that the three greatest problems in physics were problems that he never worked on and really nobody else ever worked on during his career. And those three problems were time travel, teleportation, and anti-gravity. And it's not that those weren't problems for which a solution would have had an impact. It would have actually changed the world, and it would have given you a reputation that would have lasted centuries, along with your Nobel Prize. But the problem is nobody has a faintest idea how to attack those problems, how to approach those problems, and therefore it's a waste of time sort of working on them. So good problems have the characteristic that they're really important in their impact, and you have some idea how to tackle them. So if we bring this back to the world of APIs, one very common way to think about an API and the purpose of an API is that it's a way that two pieces of software can communicate across the network. I have a client and a server. The client needs to get at data or to invoke actions on the server, and we want the communication to be fast, secure, and easy to program. So it seems like many people come at APIs with that as sort of the problem definition. That's actually not, at least by Hamming's definition, an important problem in our field. That doesn't mean that it's not important. That could be I've worked on many projects where those were solving that problem was important, but this is actually a solved problem. There are several good technologies for doing this. You just have to pick one if you think that this is what your primary problem is. Here are some different goals that you might have if you're defining an API. And these are important problems in our field, and these are unsolved problems. So one important problem is that software is just basically hard to change. And every enterprise that I've ever worked in, or every enterprise that I've had contact with and worked alongside with, which is a much larger number, has had the problem that they're essentially prisoners of their existing software. You build up, unless you're in the first few months of a startup, you have a legacy of existing software. And it's never what you want. It's never what you want for your business needs. The business scenarios change, the business needs change, and it's never really what you want from a technical point of view either. Once you've done something, you always immediately learn how you could have done it better. And so you're stuck with it, and it's difficult to change. It's difficult to change because it's complicated, and it's difficult to change because in almost all the systems that we have, they're permeated with assumptions. We have difficulty containing the assumptions that we make, whether those are technical assumptions about which databases or which technologies or which implementation languages we use, or whether those are business assumptions about what actually the scenarios are that the system has to support, which is also something that changes. Software is also very hard to integrate, and integration is a huge issue, especially in all of the enterprises that I have worked in. Almost all the enterprises that I've worked with have some kind of initiative to get a 360-degree view of the problem, which is basically how do I integrate all the information that I have about a customer. Or they're trying to integrate the total experience. They have many points of contact with a customer, and they're trying to integrate those things together. Many of you will have traveled here to the conference when you made your booking. That's a big integration app, dealing with hotel reservations, your credit card, your flight reservations and things like that. And when you go back and do your expense report, assuming that you have a reasonably modern sort of expense report tool, which I'm sure most of you have, that's another big integration app. It's integrating your credit card bills. If it's a nice modern application, your flight receipt and your hotel receipt will already be known in your expense report and associated with your trip, that kind of thing. It's all a big kind of integration app. So a huge amount of the development that I see is in fact integration development. We build up these little sort of silos, and then we realize that there's a large amount of value if we can integrate those silos. Software is hard to integrate, often because basic APIs are not available. So it's difficult when you can't get at the data that you want to do, and also because it's an n-squared problem. Every system has its own unique API, so if you're trying to do an integration thing, you get to learn the APIs of all of the systems that you're trying to integrate. I believe that some styles of API go beyond the first problem. They go beyond simply efficient, easy-to-program communications between two distributed components, and they offer a significant attack on those two major problems. Of course, there are other major problems in software, like software quality is a huge problem, but I don't have an attack on that one, so I left that off my list. But I think APIs provide an attack on those two major problems. There are two dominant styles of API. One is the entity-oriented style, sometimes called REST. I'll come back to that word in a minute. And in that style, the client code manipulates the entities that are exposed by the server. And the behaviors of the system are hidden behind those entities. What I deal with is the entities themselves. I can create entities, I can update entities, I can relate entities to each other. What the system actually does is a side effect of those entity-based sort of operations. An older model is the procedure-oriented model, the sort of RPC model. And that one is the perfect inverse. In that one, what I interface with is the procedures that you provide, and the entities that those procedures are talking about are hidden behind the procedures. So one puts the entities in front of the behaviors, the other one puts the behaviors in front of the entities. They're inverses of each other. Here's my kind of stylized thing. And actually, you'll probably be annoyed at this chart. I'm a little annoyed at this chart because it's trying to make a point which I actually believe is true. And the point that it's trying to make is that in the procedure-oriented style, typically what you end up with is a very large number of these procedures that you have to master. So there's a lot of these basic procedures or functions that you call that you learn a long list of. The entity-oriented style has more structure, and the problem with this chart is that it's not really balanced on each side. The procedures that I'm showing actually imply a number of different entities. There's the dog, there's the owner of the dog, there's the veterinary surgeon that deals with the health of the dog. So if this were really a balanced one, I would have multiple entities on the left-hand side. But the point that it's trying to make is that there's much more structure on the left-hand side. The left-hand side is like an ER diagram, an entity relationship diagram. I understand what the basic entities are. I understand the relationships between them. But the actual methods that I call are very limited, and they're always the same. In the procedure-oriented style is very similar to learning the libraries of a programming language. And I think this is one of the reasons why RPC has been perennially popular with programmers, because it's very familiar. You learn a programming language, you learn the libraries of the programming language, and learning a distributed API that is written in the RPC style is just like learning another library. It's not really very, very different from that. But one of the characteristics is all of those APIs are different. The entity-oriented style is much more similar to learning to use a database. So one of the characteristics is if you use whatever your favorite database is, MySQL or Postgres or Oracle or whatever it is, a fundamental characteristic is that there is only one API. It doesn't matter how many databases you have, the database management system that hosts that database defines a single API that's used for all of them. So you only ever learn one API. Now, when you go from database to database, you have to learn the schema of that database. You have to learn the tables, and what are the tables, and then you learn what are the columns in that table. Or if you're using a MySQL database, the terminology changes a little bit, but the concepts don't change very radically. So the entity-oriented approach has this very interesting characteristic of solving the n-squared problem. Instead of having an individual API for each system, I have one universal API that's used with all the systems. I gave this talk, I practiced this talk. I'm not actually it's not very common for me to practice talks, but Google wants us to do the best that we can for you guys, so I was encouraged to practice this talk. And when I gave this talk internally, somebody said, are you really telling me that my API should just be a view onto my database? And the answer is no, that's not what I'm saying. What you actually store in your database is probably more complicated. You may have multiple tables for each entity. You may not even have tables for your entity. Your entities may be assembled from information that you get from other services. So it's not about taking your database schema and just exposing it as your API, but it is about using the same kind of concepts, the same conceptual model for an API that you see used for a database. So if we're going to attack these important problems, our problems was it's hard to change and it's hard to integrate. Some of the characteristics from APIs, especially the entity-oriented APIs that will help us here, is one is having a uniform API across all applications. That helps with our n-squared problem. Another one is having a uniform model for relationships. I'll talk a little bit more about why relationships are so important in this. And then the third one is staying free of implementation assumptions. So how do we get that from this kind of entity-oriented API? I said I'd come back to the REST term. REST API is actually a little bit of an oxymoron because one of the primary rules of REST is, what was REST? REST was one man's attempt to write down the architectural principles that underpinned the HTTP web. So it's really a description of the architectural style or the architectural principles of the HTTP web. And one of those principles is uniform interface, which means that there really only is one interface. So when we talk about a REST API, there's only one important REST API in the world, and that's HTTP. So when we talk about REST APIs, what we're really talking about is how do we just use HTTP exactly as it is, and apply it to the domain of APIs. Really what we're saying is, don't layer concepts on top of HTTP, just use it as is. It is the universal API. Unfortunately, HTTP has some gaps here. HTTP actually tells you how to do CRUD in a nice way. HTTP does not tell you how to do query, for example, and query turns out to be very important for almost all APIs, and neither does it tell you how to do versioning. So there is some amount of invention required beyond the sort of universal API that's provided to us by HTTP. How do you actually leverage this uniform API, this HTTP API? Well, again, it's a lot like what you would do with a database. The first thing you have to do is you have to define a few well-known URLs, for example, /customer/account/orders, which is very analogous to defining what the tables are if I'm defining a database schema. And then I have to define the actual resource schema, which is very analogous to defining what are the columns for each one of those entities. And then the rest of the problem is don't mess up the basics. So when we have to start adding query and adding versioning and things like that, do it in a way that's compatible with this standard API that we want to show. So here's something that's very typical. So here's a kind of simplified version. And if you've worked at all in sort of, HTTP JSON APIs, I shouldn't think there's very much here that's not familiar to you. But the thing that I'm highlighting is this ID:12345. And when you do that, you've already stepped outside the uniform interface. And the reason is that the uniform interface that we're trying to use, the HTTP interface, requires URLs. It doesn't require simple numeric IDs. So if I'm going to write my identifiers this way, I'm going to require extra information about my API. I'm going to have to describe in the documentation how you take one of those IDs and how you transform it into a URL that can then be used in the API. And this was unfortunate because it would have been just as easy to do that. And if I'd done that instead, then now I stay within the uniform API. I don't require you to have extra out-of-band information about my API in order to use the universal API, which is HTTP. So very small change, but these things sort of make a difference when they're accumulated. Relationships are extremely important. Relationships are extremely important when you're designing a database, and they're also extremely important when you're designing an API. One of the reasons is that APIs, the fundamental problem in most integration projects is creating relationships between entities that are stored in different applications. Sometimes I'm trying to get at function through a particular API. But in many of the integration examples that I gave earlier, for example, your expense reports or your travel booking, are all about relating entities to each other. I'm taking this flight along with this hotel reservation, and I'm linking them all together with this trip ID. So I'm relating entities in different systems. Relationships are a very fundamental way that we think. Thinking about the world in terms of entities and relationships is an idea that goes at least back to Plato and Aristotle. I put their pictures here just in case you come across them at the conference and want to talk to them. A major obstacle in relationships depend on identity. I cannot reason about a relationship unless I can reason about identity. I can't say John loves Mary unless I can reliably identify John and reliably identify Mary. So one of the primary obstacles to these kind of relationship-based integrations through APIs is the struggle that we have with identity. And here, the universal API, the HTTP API, makes a huge contribution by defining the concept of a URI, or a URL, which gives us the ability to across all of our systems, write identifiers in a way that's standard and repeatable and storable and all of those kind of things. But again, we tend to make mistakes here. So here's I'm particularly. Oh, I've got the wrong pointer here. Didn't mean to do that. So here, focus on this last line. So this is a very typical way that you'll see people writing or attempting to write relationships in a typical sort of JSON API. They write owner ID. Owner ID is the field that I've used to capture the owner, and I give its numeric identifier. Now, the problem with this is that this identifier, I need a lot of contextual information. I cannot just use the uniform API to follow this link, because I need contextual information. I need to know where I plug this in, which other systems can I plug this value into, and how do I plug that in a way that creates a URL that I can then use. And in fact, this breaks down in different ways. I mean, supposing I have different kinds of owners, some owners are police dogs, right? So, or rather, police dogs have a different kind of owner. In that case, the owner of the dog might not be a person; it might be the police department or something like that. So, how do I know? How do I know to resolve this number by looking in the system of institutional owners as opposed to personal owners, those kind of things? And we could have avoided all of those problems if we'd simply written it this way. In other words, owners the relationship and give a URL. If the URL is in the same system, you can write it relatively. I can resolve a relative URL knowing only the standard specifications, published by IETF. I don't have to know anything specific about your URLs or your systems to do that. Or if this references something in another system, then I write the URL in its full form. You might think about how do you do this kind of example with RPC? With RPC, it's probably even more complicated. With RPC, you have to take something like this, and then you have to know amongst all of the remote procedures that I could call, which are the ones that will take something like this as an argument. So having a uniform model for identities is extremely important, and the simplest way to do that, to leverage the universal interface, HTTP, is make every ID a URL. Another thing you should do is not confuse identity with name. So thinking about identity is very important. It's very important if you're going to make this thing work. So think careful about identity, and don't confuse identities with names. So what is a name? Well, here's a nice description of what names mean in English, going back to 1597. This is Romeo and Juliet. You all know the story, right? In fact, this is one of the most famous passages in all of the English language. And so Juliet would have made a terrific API designer. She thinks very carefully and very clearly about concepts. What she's saying to Romeo here is that your name doesn't really matter. Your name does not say who you are, and you can cast off your name if your name's not convenient. Doff thy name, Romeo, which is very different from your identity, right? And so names are terrifically important things. They do have a place in APIs. Many well-designed APIs support names, but they do not confuse names with identities. So here's an example. Here's a good identity. This is a pretty good identity. This is a very simple. Doesn't matter what kind of resource it is. No amount of change. This pet. Well, maybe there's a problem with this actually, because something that is a pet. So, for example, if I have a goat that's part of a herd, that's really just part of my. This is one of my possessions, and then I take pity on one of these poor sick goats and take it into my house. It became a pet. So something changed here, right? So this actually might not be a very good identity. Because it refers to a characteristic that might actually change. Something that was a pet might not be a pet if it's just put out in a field with the other kind of animals. The important things about identities is that they're immutable. They're not based on some characteristic that might change. I see lots of people trying to make identities that look like this. And it's very attractive, right? Because this kind of identity, 1, 2, 3, 4, 5, nobody can remember that. But you can remember that, Lassie was a dog, if you remember the Lassie story from the movie. Lassie, there was a dog that belonged to Joe Carraclough. Unfortunately, Lassie was taken away by the Duke of, I forget, whatever. So not a very good identity because Lassie changed ownership in the movie. But it is useful to have URLs like this because it's very useful to be able to look things up by name, but you have to be aware that names can change. And in fact, that brings us to query. So one of the things that I warned you about is that basing APIs on HTTP is a very powerful technique, but there are gaps in HTTP, particularly around how you deal with query. And in fact, this URL, which is basically saying, find the dog or the pet called Lassie that belongs to Joe Carraclough, can be rewritten this way. It's really just a stylistic difference, but both of these are queries. This is not a URI in the sense, well, it's a URI of a search, not the URI of a dog. And it's more, if you write the URL this way, it doesn't really change the meaning, but it does make it a little bit more obvious that in fact, this is just the URL of a query. It's not the URL of a particular dog, and it's not guaranteed, because it's a query, it's not guaranteed to give the same result twice. Let's talk about representation. So representation in HTTP is the word that is used to mean the actual format of the resources. So if I do a get on a particular resource, what I get back is the representation. JSON, in the HTTP world, JSON is the most common sort of language that we use for writing down those representations. But one of our design problems as an API designer is what should the JSON look like? And there are lots of options. If your focus is the first focus that I talked about, that your primary reason for building an API is for efficient communication between two components on the network, then the kinds of things that you're going to focus on is you want things that are efficient, you want things that are easy to parse, you want a good match for the programming language on each end. Those are going to be your sort of primary values. If your focus is how do I make things easy to integrate, and how do I make things easy to change in the future, your focus is going to be different. Your focus is actually going to be independence from technology, because you may want to anticipate different clients of the same API that will show up at different points in history. And resilience to change is much more important to you than things like ease of parsing. And sometimes these are in conflict. So you may have to make up your mind what's important to you. If you're working directly with the implementation teams, they have a lot of biases, and they will push for certain things. They won't like homogeneous collections, for example. They want things that are easy to parse, and especially if you're working in a typed language like Java or Go or something like that, it's easier to parse things. It's not impossible to parse things if you don't have this, but it's easier to parse things if you know ahead of time what the types will be. So don't give me a collection that has a lot of different types of things in it. I don't want the famous Sound of Music, my favorite things, raindrops on roses and whiskers on kittens, right? So those are all different kinds of things. Don't put them all in the same collection, because I find that harder to parse. Closed content, don't tell me that you don't know ahead of time what all the fields are, because in my parsing routines, I really like to know what all the fields are going to be ahead of time. So, you'll get these kind of things. I'll show you what I mean by index collections. Union types are unpopular. Don't give me a field that's sometimes a string and sometimes an object. Don't really like that. It makes it harder for me to parse. So you get lots of these kind of constraints coming from developers of things that they don't really like. As an API designer, if your goals are the big problems that I talked about, I think you have to push back on some of these things. Some of these things are fine. It's not always a good idea to have a single variable that's sometimes a string and sometimes a number. But if you think it makes conceptual sense, then maybe you should push back on the implementation teams who've got specific constraints. Yeah, here's an example of what I mean by index collection bias. And this is actually, I copied this out of an old Facebook API. This may not be current, but there's a Facebook API for listing photographs. And you can see the way the data is organized is actually reasonably complicated. What did I do with my pointer? What happens is that the outer name in the JSON thing is actually the user ID, and then the inner stuff is a set of photographs for that user. And then we start with a second user here, and then we have a block that's the list of photographs for that user. And when you design JSON this way, what you're really saying is that you're favoring one particular access pattern for the data. You're assuming that the primary usage by the client will be that they'll want to access the photographs based on the user ID. If they wanted to access the photograph based on creation time or something like that, this is actually not a very friendly data structure. So within this data structure, you've sort of advantaged one set of access patterns and disadvantaged another set, which might be okay, but it might have been better to do something simpler like this. Flatten the whole thing out. So if I'd flattened the whole thing out, well, first of all, it's simpler because it's much flatter. And what I really did was I took these user IDs and I moved them into the block. This is going to be less convenient to use if my primary access method is accessing the data by user ID, but if I'm accessing it by some other criteria, it's actually better. I actually prefer this. So I prefer the second form because I'm more open to change. If I have different users that have different access patterns, I haven't penalized the second set of users because I optimized my data representation for the first set of users, even although the first set of programmers were probably pushing me to do something like this because they wanted something that was convenient to their access pattern. I'm very public-spirited, so I have taken the trouble to write down a set of possible rules. I'm not claiming that these are the only rules that you need to follow if you're going to use HTTP well, but I tried to write down a set of rules that explain how you can use JSON in perhaps the most simple form possible that might be helpful. And the reason I like it is it's more abstract, it's less geared towards one particular access pattern. So versioning, queries not dealt with by HTTP, neither is versioning. And versioning is a very confusing topic. One reason is there's at least 3 meanings of versioning, and it's very common when you hear people talking about versioning for people to talk past each other because they are each thinking about versioning a different way. They're each thinking about a different aspect of versioning. And you sometimes find people even getting themselves confused by using the word versioning in 2 different ways in the same sentence and getting muddled. So one kind of versioning I have dubbed here entity versioning, which says there are multiple versions. So I have a particular kind of an entity. I have a travel trip or something to stick with our previous example. I introduced version 1 of Travel Trip, and then that was successful for a couple of years. And then I had a major upgrade, and we completely reworked our data model. Because we reworked our data model to accommodate some more advanced scenarios, the old trips and the new trips are different. So every time I create, so I introduced a version 2 of my system, but when I introduced version 2, I started creating version 2 trips. So every trip is either a version 1 trip or a version 2 trip, but not both at the same time. So they're a different set of entities. So that's a very common thing that happens when you make a major change to your data model. Another kind of versioning is what I have dubbed, this is just a personal vocabulary, but I have dubbed format versioning. And what happened there was I introduced trips and I gave them one JSON representation. And then I realized from feedback from my customers they didn't like the names that I chose for the properties, or they didn't like the way that I organized the JSON. Maybe from the previous example, I'd organized it the first way, and they really preferred I organized it the second way or the other way around. So I decided to introduce a version 2. But the important thing is that each trip can be viewed either as through the version 1 format or the version 2 format. They're not 2 different sets of trips. They're the same trips that can be viewed in 2 different ways. The third kind of versioning that you hear about is where you keep prior revisions of the same thing. So if I have a document, a Google Doc, for example, and I keep changing my Google Doc, I may have a long revision history for that thing. And you use these in different in different places. You know, if you use entity versioning, if you've made a significant structural change to your data model, you use format versioning if you're making small changes to the representation of individual entities, and you use historical versioning if you're doing things like creating an audit trail and doing undo redo, and they're all different. So having got clarity on that, let's look at format versioning, because that's the one that I think people do most commonly with APIs. And let's look at some of the mistakes that they make. So I'm doing format versioning. So one thing that you'll see people commonly doing is this. They put a version number in a URL that they then use to try to make a link. And that doesn't really work well. And the reason that it doesn't work well is that just because I wanted version 1 of Lassie does not mean that I want version 1 of Lassie's owner. And in fact, there may not even be a version. Let's say I ask for version 2 of Lassie. There may not even be a version 2 of Lassie's owner. Owners may only have a version 1. So it's not possible for the server to select the version to use in a link. So what that means is you got one or two choices. Either you don't put version numbers in links at all. That's one possibility. So that will solve the problem. Or for each entity, you need to provide a URL, one that does have the version number in it and one that doesn't. And the one that does not have the version number is the one that you will use in links, and then customers or clients can transform that into a URL that does have a version number if they want to select a particular version. So either of the strategies will work, but what will not work is trying to use links that have trying to use URLs that have version IDs in them in links. So you might protest that if I do this, okay, let's say I take all of this stuff out. So I've taken all the version numbers or version identifiers out of the URLs, but then I've lost some information. Well, you can put it back if you like. You know, invent a property instead for, my pointer stopped working. Has it? Yeah. Invent a property that tells you which version number or which version format you're looking at when you're looking at this. And if you also want to give out an ID and also tell me exactly which version or which version I'm looking at of the current one or the URL of the current version, you can use something like this. And these values actually probably fit better with the style of HTTP if we put these in headers, but there's certainly no harm in having them in properties also. A lot of what we're doing here is just not messing things up, right? We've got this universal API called HTTP. We know how to work it. It works based on URLs. Just follow the pattern. So as you're designing things and you're having to add things that are missing out of HTTP, do it in a way that doesn't mess up the basics of how HTTP is actually used. So the right way of doing versioning is every entity has a version-free identity URI. You can allow clients to use the version-free identity URI directly by having an accept version header, or you can allow them to transform the URL into a different URL that does have the version identifier in it. If you do that, then you're having to provide basically a transformation algorithm that's specific to your API. It's not a generic part of the protocol anymore. So I'm going to wrap up here and invite you to ask questions. But my conclusion slide is decide what you really care about. If you care primarily in this particular application that you're doing, if you care primarily about efficient communication between tightly coupled components, there are lots of great choices out there. gRPC is the one that's favored by Google, and it's a great choice. If what you're focused on is latency and throughput and efficiency and ease of programming, RPC does all of those things very well. If you're aiming for something more abstract, that you're creating your APIs because you're primarily interested in decoupling systems so that they're more adaptable to change in the future, or you're primarily interested in creating APIs that will enable integration scenarios. And actually, one of the most important integration scenarios, which I failed to mention earlier, is the one when you're publishing an API to your partners or customers. So if you're creating APIs that will be consumed only internally within your own, or you think will only be consumed internally within your own organization, it may be that the top set of concerns might be the ones that dominate your thinking. If you're creating API, although actually I would challenge that, but anyway. But if you're creating APIs that will be used by other people, that will be consumed by development organizations over which you have no control, you can't control the rhythm at which they change things, you can't control the way in which they version things, and you cannot anticipate all the different ways in which they will access your data. If that is what you're designing for, my recommendation is don't use an RPC model. Use an entity-oriented model, and in particular, use HTTP JSON as directly and as simply as possible, requiring as little as possible extra information about your specific API that they cannot glean directly from the internet standards. So that's my talk.